Okay, girls. Last time we talked about relationships, right? So let's start with a question. Diana Peralta. What is the difference between mutualism and parasitism? They both benefit? Give me an example. What would be an example? Okay, how about one that we never talked about, but I want you to think about this. So I'm going to give you one organism. You would tell me the other organism that would benefit itself and also the organism that I'm going to give you, okay? A flower and a bee. Very good, okay? Flower and a bee. Mutualism. What would be an example of parasitism? Yeah.
Like the thing on the
No, that's commensalism. Yep, tick. Well, ticks would carry parasites, right? Like, well, here's the thing. A parasite is defined as a eukaryotic organism. So bacteria would not classify as a parasite. And I think Lyme disease is caused by a bacteria, so it wouldn't be classified as a parasite. But like something like a tapeworm that lives inside you, that's a eukaryotic organism. So remember what a parasite wants to do, right? Does it want to kill you and eat you? No, that would be what? That's a predator, right? Eating its prey. A parasite wants to use you, harm you, but use you, try to keep you alive as long as possible. Today what we're going to do is talk about strategies, okay? Because I said to you that ecology is like a game. The way you win the game is by having as many babies as possible. So I'm going to talk a little bit about strategy. So let's talk about how populations are organized, okay? So there are three examples up here of the way populations are organized. I want you to think about us, humans. Which pattern would humans fall under? If you were to look at where people are living in Canada or around the world, would it be clumped? Would it be uniform? Or would it be random? What do you think? It's random? It would be clumped. Where would you find most of the people? Where though? Where in Canada? Where? You would find most of the people in certain areas in Canada, right? Like maybe like Montreal, Toronto, Vancouver, right? And you can go to other places of Canada and find hardly anybody. So it would definitely look clumped. What do you think this is? It's kind of hard to see from this angle, but if you were to look top down, yeah, it is uniform. Why? What's the strategy here? What might work for one organism might not work for another organism, right? So the strategy for this bird is, hold on, we got an intruder here. Let me pause this. All right. So what's the strategy here? Population organized in what way? Yeah, uniform. So these guys, what they're doing, let's see these birds, they have a little basically a little piece of territory each. And that territory is, I don't know the exact size of it, but it's basically over time, they've basically hit on the strategy where every little bird has a nesting site that's probably like maybe has a radius of maybe a meter or so. And basically they're just defending that area. So you have this colony set up where everyone has a little nesting site that is about 1 meter in radius or so. And if you do that, you get a uniform pattern. Because every bird has a particular radius that they're protecting. So what happened if you, as another bird, kind of got too close to that nesting site? Yeah, you would have a bit of a problem. That strategy is much different than what you're seeing here. What does this look like to you? This looks like what? Which of these three patterns does it look like? Clumped. Why? Okay, so I'm going to ask you a question. Do all fish do this? Because they're clumped up. That's very funny. Do all fish do this? Do sharks do this? No. Okay, what's the advantage of doing something like this? Because obviously if you're seeing this behavior, there has to be an advantage to doing this, right? Yeah, it's a general rule in biology. If you're seeing something in nature and it's been there for a long time, it's there because it's successful. If it wasn't successful, natural selection would have eliminated it. So if you're seeing this behavior in certain fish, and it's not just this type of fish, you see birds do it too. Birds, when they fly, and there's a bunch of them, they'll clump together like this. What's the advantage of doing this? Because there has to be an advantage. Well, I think supposedly the advantage is it offers protection against predators because it confuses the predator when they're trying to go in and catch fish. But I also think that it's a disadvantage too, because what would the disadvantage be? Yeah, there's a bunch of a predator can easily spot the prey. So it might be hard to catch one individual fish because maybe it's confusing when they start moving around, but you do draw a lot of attention. By the way, this is probably the reason why zebras clump together too. If you ever look at zebras when they clump together, what a lion would see, this probably explains why they have stripes. You just see a bunch of stripes. And it would be very hard and confusing for the lion to pick out a zebra in a group because all you see are stripes. So the advantage of clumping there would be to confuse the lion. Okay, so we're talking about strategies today. Let's talk about reproductive strategies, okay? So what I mean by reproductive strategies is we're going to look at two types. Now, I'm only going to talk about two types. There's more than two types of strategies because you can see that on this graph there's actually three types of strategies. Well, I'm going to focus on two. Okay, these are called survivorship curves. And again, we said there's more than one way to go about your business. There's more than one way to survive and have babies. Lions do it one way, mosquitoes do it a different way, snakes do it differently, right? Everyone's got their own little strategy. So what this graph is showing you is that some organisms have a strategy where you can see, this is the length of time on the x-axis. This is the number of survivors, okay? So some organisms will survive, have a very good chance of surviving to old age, and then they die off. And other organisms have a very small chance of getting to old age. So, what are we? What would we follow? What curve? Type 1 or type 3? Yeah, type 1. When you think about it, a human has a very good chance when they're born of making it to old age. What would be an example of an organism that when it's born has a very slim chance of making it to old age? What do you think? And it usually follows a particular pattern. Usually things that are bigger, have less offspring, and take care of their offspring would be type 1. Okay? Usually things that are smaller, have lots of babies, and don't look after them are type 3. So what would be an example of something that's smaller, has lots of babies, and doesn't take care of them? Very good. Turtles. After I record this, I will show you an example of baby turtles hatching on the beach and trying to make it into the water. Most of them don't make it. The same is true of fish, okay? Some fish will lay millions of eggs, and maybe only 1 or 2 of them will survive. Think about that strategy, okay? Spiders are like that. Most insects are like that. Most insects do not take care of their young. They have lots of babies. Most of the babies die. That's the strategy, but the human strategy is very different. The elephant strategy is very different. What's our strategy? What do? We have very few babies. They take a heck of a long time to grow. And we spend a lot of effort and time looking after them, right? So what's the better strategy? Jerusha? It depends, right? For the fruit fly, it works well. So they use type 3 strategy. I'm calling it a type 3 strategy. They follow a type 3 survivorship curve because it works for them, right? It works for them because they both work. One strategy is have lots of kids, don't take care of them. Eventually, one or two of them will make it. All you need are enough to make it to replace the original population. The other strategies have very few kids, but spend a lot of time on them. Both strategies work well. Okay? And again, a big determining factor in the survivorship of the offspring is parental care. So things that spend a lot of energy taking care of their young and watching after them would probably follow a type 1 curve. Okay? Probably follow a type 1 curve. Alright? So that brings us to, like, basically, you gotta think of this as a trade-off, right? For every strategy, there's gonna be benefits and there's gonna be costs. So what would be the benefit of having, so here's a graph that shows you basically the size of I think this is in birds. Yeah. This is a graph for birds and what's the clutch size, which is the number of eggs that they're producing. What's the advantage of having less eggs? What chance of each one making it is. So on the y-axis is the chance of them surviving. The less eggs, the chance of each individual surviving is higher. More eggs, the chance of each one is lower. And that makes sense because if you have more mouths to feed, it's harder to feed them. But what's the advantage of having less eggs? Oh, sorry. What's the disadvantage of having less eggs? You have less babies. And remember, the name of the game is to do what? To get as many babies as possible into the next generation, because those babies carry your what? They carry your genes. So when we look at reproductive strategies, there's two types. There's the K strategy, which is these ones are organisms that have less offspring. They're bigger. They take longer to reproduce. Okay. So here's some information about them. Typically large. Typically live long. And then you have the other ones, which are the R strategists. I remember R for rapid. So they're small, they grow really quickly. I think of them as live fast, die young. Okay? And again, little or no parental care. Here is a summary chart that compares the two strategies. What's better? There is nothing. Like, you can't really answer that question. So what works really well for things like mosquitoes would not work well for other organisms. Again, we like to classify things, but sometimes we come across, an organism is an organism. It doesn't care how you classify it, whether you say it's an R or K strategist. It is what it is. So sometimes we find things that are, we don't really know where to put them. They're not really R, they're not really K. So let me give you an example. Where would you put a mouse? Where would you put a mouse? R or K? Yeah, I probably would lean it towards R, right? I would lean it towards R because they're small, they have lots of babies, they mature really quickly, but do they take care of their young? Yeah, so my point is, you're gonna find some organisms that might show you some R and K characteristics. I would probably lean mice towards R. But what about a tree? What would a tree be? Well, a tree is big. Does it reproduce really quickly? Takes a long time. So that's K-like. But does it take care of its young? No, so that's R-like, right? So sometimes you come across organisms that are a little bit of both. Okay. What's that? A cat? That's a good question. I would say a cat is probably slightly more K-like than R-like. Because, I mean, cats don't live very long, but they still live a good, 15 years? Lions probably live around 7 or 8, right? Whereas some insects will live a matter of days. There are some insects out there that will live literally only a few days. The mayfly, I believe, is that. The butterfly will live a little longer. And again, it's going to depend on the type of butterfly. But generally, insects do not live very long. But then there are some that do. Like spiders, which is not an insect, can live many, many years. Okay, so these are reproductive strategies, right? So let's take a look at some other strategies. Let's take a look at down here. Well, here's an example of what? Okay, so even think about this. We're going to come back to strategies, but before we talk about strategy, I want to talk about coevolution. This is an important concept, understanding the strategies, okay? You guys studied evolution in grade 11, right? So coevolution is just the evolution of one organism in response to another organism. So when two organisms co-evolve, they form this really tight relationship. So for example, flowers and bees, or in this case, flowers and birds, right? And then there's this one, which is my favorite, which is the bee orchid. We talked about this one. This is an example of where this orchid has co-evolved with a bee, so it looks kind of like a bee. So what the tight relationship here is quite interesting. This orchid actually generates a smell of a female bee that wants to play chess. I'll say play chess. So there's a tight relationship here between this flower and the bee. This is an example of coevolution. Now the reason why I'm telling you this is because we're talking about strategies today, right? So for you to understand strategies, like you need to understand, like if you understand why a mosquito does what it does, you need to understand its relationships and what it's co-evolved with. If you want to understand why a lion does what it does, you need to understand what it's co-evolved with. What's that? I don't know. I'm not an expert on mosquitoes. But you'd have to know what its relationships are with other organisms. You have to know what it's co-evolved with. I know some things about mosquitoes, but I'm definitely not an expert when it comes to mosquitoes. So let's talk about some things like defense. Okay? So some organisms evolve certain defenses, right? Like, for example, some plants have big, nasty thorns or spines. Or maybe they produce dangerous chemicals, right? And then you have other organisms that will eat or go after things that are dangerous. So, for example, this is the monarch caterpillar. It will eat the milkweed. The milkweed is toxic. Why in nature do you see animals going after other animals or plants that are dangerous, that are toxic? Like, that strategy seems very bizarre. So in some cases, the advantage of doing that is by stealing. So if you're eating something that's toxic, you could literally take its poison. So some organisms will do that. This one does that. But that's rare. What's the point of going after something that's dangerous? Like, as a strategy, that would seem kind of stupid, doesn't it? So I want you to think of this, okay? Imagine this strategy is analogous to the person that works on, like you gotta think about like, those really high buildings, like someone had to build those. Someone had to literally be hundreds of meters in the air working on a building. Or those guys that clean the windows really high up, someone has to do that. That's dangerous. What's the strategy in doing something dangerous? Less competition. Right? Less competition. So, if you can go after something that's more dangerous, and you can do it well, you'll have less competition for that food source. So, we're talking about strategies today. So think about that. Like, you would not understand that strategy unless you thought about, okay, what is it competing with? What are the other organisms in the environment? Even though it's doing something dangerous, is it doing something that nothing else can do? Because that would give it a major, major advantage. Let's talk about some defensive strategies. Okay? What's the strategy? And by the way, this is called aposematic coloration. All right? What is the strategy that this frog is employing? Because it definitely isn't camouflage. What's their strategy here? Think about this now for a second. Okay? This is a tiny little frog. Right? Tiny little frog that is brightly colored. Black and yellow. Black and yellow, black and yellow. Like, that sticks out. Why? Why is this frog doing that? Because not all organisms do that. Some organisms will do this. This is the opposite. This is camouflage. This I can understand. If you're trying to eat something like this, you might have a hard time finding it. This is weird for me. Unless you're like the biggest, baddest animal in that ecosystem, and you don't care about other things in the environment, you can be as brightly colored and obnoxious as possible. But this isn't. This is a tiny little thing. What's the strategy here? What do you think the strategy is? So you think the strategy for this little frog is to bring over predators? Yes. So somehow, over time, the predators in this environment have learned, and to me it's a bit of a baffling thing how this works, but they have learned that stay away from brightly colored little things. Because one of two things. Either it's dangerous, or it's bluffing. Because there are organisms that are brightly colored, that are not dangerous, and they're bluffing their way. Which is a strategy. Sometimes things are legitimate, and they're dangerous. Sometimes they're just bluffing. And we'll talk about that in a second. So here's camouflage. This is an easy strategy to understand. But this could be used for protection, but sometimes it could also be used to attack things. Like, you could use camouflage to ambush something, right? Because if they don't see you, then you could capture them. But this is for hiding, for protection against other predators. Another strategy would be trying to look like something else. So there's two types. There's Batesian mimicry, and there's Müllerian mimicry. Okay? In Batesian mimicry, the idea is that you are going to try to mimic something that is dangerous or something that is very distasteful. So, for example, this snake is not poisonous. This one is. The strategy here is, if I'm this snake, and I can look like a dangerous snake. By the way, and they don't choose to look like a dangerous snake. But what happened is over time, this organism evolved to look like this organism. And we can probably easily understand how that would have happened. Any predator that knows that this thing is dangerous will tend to avoid anything that looks like it. So this is a king snake. So if you're a king snake and you look more like a coral snake than your neighbor, predator might leave you alone. So over time, you're going to get king snakes that tend to resemble coral snakes. So the advantage here is simple. If I look like something that's dangerous, they'll leave me alone. Because again, either I am dangerous or I'm bluffing. Right? But in this case, I look like something that's dangerous. So there's a good chance that a predator may leave me alone. Now, you had a question? No? The other strategy is, so that's Batesian mimicry, when you that are not dangerous, or you that are tasty, look like something that is not tasty, or something that is dangerous. Müllerian mimicry is when one thing that is both is either dangerous or very distasteful looks like something else that is also dangerous or distasteful. Okay? So here's an example of two butterflies that look like each other, that if a bird was to eat them, would have a really bad experience. They would get violently ill, and they would throw up. So imagine a bird eats the monarch butterfly and has a really nasty experience. If they come across another one, they'll leave it alone. If they come across the viceroy, they'll leave it alone. Why? Because it looks like the nasty one that it just ate, right? Now, your book actually has this as an example of Batesian mimicry. So this was actually initially thought to be Batesian mimicry. The reason why is this is the monarch butterfly. Remember, butterflies come from caterpillars. The monarch caterpillar eats the milkweed, accumulates the poison. So what happens then is the monarch caterpillar becomes the monarch butterfly, and it's accumulated all that poison. A bird eats the monarch butterfly and gets really sick because of the poison. And then if it sees a viceroy, we'll leave it alone. Your book says that the viceroy is tasty, but the bird will leave the viceroy alone because it looks like the monarch. So apparently that's not true. Apparently they did an experiment where this was kind of mean. They took the monarch and viceroy and they fed them to birds. But before they did that, they ripped off the wings. Now why would they do that? Yeah, because the wings give away the butterfly, right? So what they did was they did that. They fed the birds, both the monarch and the viceroy, and the birds did not like both of them. So they were both nasty, both very distasteful. Your book says that the viceroy was very tasty to the birds, but apparently it's not. So this is actually an example of Müllerian mimicry. So in Batesian mimicry, the mimic looks like something that's dangerous. It's not dangerous, and it's tasty, and it can be eaten, but it looks like something that can't be. In Müllerian mimicry, the mimic is also dangerous. It's also distasteful, and it looks like something else that's also dangerous and distasteful. Why what? So I guess in a sense they're helping each other out, right? They're helping each other out. Okay, here's another example. This is going back to camouflage. So what do you think this is? Without reading the caption. What's this thing trying to? So I would think this is more like, so to me there's a bit of a fine line between camouflage and mimicry. Mimicry, you're trying to look like something. Camouflage, you just blend in. Okay? So what do you think this is trying to mimic? I don't know if you want to classify this as mimicry or camouflage, but yeah, it's trying to look like a rock. This is actually a plant. Believe it or not. What do you think this is trying to mimic? Now, is this mimicry or a camouflage? I mean, sometimes it's a bit debatable. So if we can think of it as camouflage, but we can also think of it as mimicry. It's trying to mimic what? A leaf, right? What about this? This is the hawk moth caterpillar. What do you think this is trying to mimic? Snake. So this is actually the tail of the caterpillar. The tail of the caterpillar looks like the head of a what? Snake, right? So imagine that you're a caterpillar and and you look kind of like a snake. That's great protection. Something might think, oh, I'm going to eat a caterpillar. And it's like, wait, I think that's a snake, so I'm going to leave it alone. Sometimes, though, what we think is camouflage is not, because we're looking at it through human eyes. And remember, if you really want to understand somebody, you have to look at, you hear that all the time, right? You really want to understand Jerusha, you got to look at it through her eyes, right? So this, if I said to you, why is this spider yellow, and why is it a yellow spider on a yellow flower? What would you say? It's trying to hide. And if it's trying to hide, two reasons. One, it wants to protect itself, or it's hiding so that if prey shows up and it can't see the spider, then it could catch it, right? Well, here's the thing. This is what a fly sees. Isn't that weird? So a fly sees this. A fly would see the yellow flower as violet, and it would see the spider as white. So you can clearly see that the spider to the fly is not camouflaged at all. So then, why do we see this? So it's probably, the spider's probably protecting itself from other things that see it this way, right? Anything that would see it this way would have a hard time spotting the spider. Flies do not see the same way we see. So I don't know what a bird would see. I would suspect a bird would probably see it more similar to the way we see it. So this could be protection against things like maybe birds, but it's definitely not using it as camouflage to catch spiders. Here's another type of mimicry. So on the bottom right is, I don't know if you could see that. This is a firefly, and this is an insect that is eating the firefly. And what this insect does, because don't assume mimicry is just looks. Sometimes mimicry is other things like smell or sound. Okay? You can mimic smells, you can mimic sounds. So what this insect does is it mimics the sound of a female firefly that wants to party. So the male firefly, flies thinking that it's going to encounter a female firefly, and all of a sudden, game over, right? On the left, top left, is an alligator snapping turtle. And the mimic is not the turtle itself, but it's the tongue. So what it does is, imagine you're a fish, and you're swimming, and the water isn't very clear, and you see this little pink wiggly thing. What do you think it is? You think it's a worm, right? So you swim up, and you see this little wiggly thing move. You get a little closer, and you see it moving. You get a little closer, and you see it moving, right? A little closer, moving. No! You're gone. Because that tongue mimicked a worm, and it lured you into striking range of the alligator snapping turtle. Is that kind of cool? Here's a picture. Why am I showing you this picture? Because we are talking a little bit about camouflage today. This is a picture of French soldiers. What's wrong with this uniform? Yeah, it's very bright. If you look at soldiers nowadays, their uniform blends in with their environment, right? So in the olden days, they didn't do that. Now, they don't obviously look like this anymore. So the reason why I'm telling you this is because obviously, just like animals, soldiers need to be camouflaged. And we talked about camouflage as an important strategy. So here's a question. This animal here is, do you think the strategy for this is a vole. A vole are really tiny, like mouse-like rodents, okay? Do you think the strategy of the vole would be to stand out in its environment? Or do you think the strategy of the vole would be to camouflage itself? Okay, camouflage itself, right? Okay, so this vole lives in an environment where its fur color matches its surroundings. So, how does a kestrel, which is flying above, spot and catch a vole many, many feet down on the ground when the vole looks like its surroundings? Now, when we smell, it's interesting. I would never have guessed this. When I heard this, I was like, what? Seriously? Yeah, you know what? That's I like the way you're thinking. You're like, well, maybe to us it looks the same, but maybe to a bird it looks like this. Actually, you're close. It's something else. So you see this vole? You see how it's on this piece of paper, and you see the paper is like tinted here. Okay. What the vole does, it actually looks what the kestrel does is it's not actually looking for the vole. It's looking for its urine. The urine under ultraviolet light does this. So the kestrel can see the urine glow from far up, and it can track the vole through its urine. And then once it knows like where they are, then it can kind of zone in and find the vole, find its food. All right, so that's it, guys. We talked about strategies today. I hope you learned some interesting stuff. Okay? The end.